In the chapter of dynamics, we have to start with the basic concepts of mass, weight, momentum, Newton's first law, Newton's second law, Newton's third law. So I hope that you already know about the basic concepts of the Newton's law and the concept of momentum and the concept of mass and weight. Any confusion? Or if you want to
No,
revise?
I
Hmm?
already know. I already know the difference.
Okay, so basically in momentum, you know that the formula, the change of momentum, the law of conservation of momentum. Then we are having a concept of terminal velocity, the graphical representation of terminal velocity. Any confusion in that?
No.
Okay. And what about law of conservation of momentum?
Law of conservation of momentum is that the sum of total momentum before collision
Mhm.
is equal to the sum of total momentum after
After
collision.
collision, yes. And same with the equation m1u1 is equals to m1u1
Yeah.
plus m1v1, right? The same concept.
And
Okay.
also, impulse equals to force times time, and impulse is also mv minus mu.
Okay. So basically, you already know about the concept of law of conservation of momentum, and the new concept that is different from your basic level is collision in 1 and 2 dimension. So if we start
Okay.
with the topic, so we have to start with the collision in 1 and 2 dimension. Okay, so in this concept, we have to start with the concept of momentum. You already know about the concept of momentum.
Yeah.
That simple product
Momentum
of
is
mass.
mass.
Yes,
Yeah.
this is the concept. And you also know about the concept of the momentum before collision and after collision, right?
Yes.
And let's suppose if we want to find out the kinetic energy.
If you want to find out kinetic energy, energy is equal to the work done,
Hmm. Okay.
and work done is it's gonna be the
Yes. And if
force
we know
times
about the
distance
and if we
time,
talk about the yes, and if we talk about the basic
and it's
formula for
half
kinetic
mv
energy,
squared.
half mv square,
Half mv
right?
squared.
Yes. So basically, we have to start with the concept of kinetic energy because we know about the law of conservation of momentum, and the collision. We have to start with the concept of collision, and in collision there are two types of collisions, right? One is known as the elastic collision.
Okay, is that new?
There is a basic concept in IGCSE, but we don't need to study very detail in that concept. So in this, at this level, we have to find out the value for elastic collision and inelastic collision with respect to the energy. So that is the new thing that you have to do in this chapter. So basically, if we talk about elastic collision and inelastic collision, so the difference between inelastic and elastic collision is that in elastic collision, the momentum and the energy remains conserved, right?
Okay.
So basically, if we take the example of that snooker ball, so because we apply law of conservation of momentum at different objects, so if we apply law of conservation of momentum on balls like the snooker ball, so you know that both are made up of very hard solid object, right? So when they collide with each other, so that is inelastic collision, right? It means their momentum and energy will not remain conserved. And if we talk about elastic collision, let's suppose if we take the example of the football or tennis ball, so you know that they are made up of rubber material. So that is a sort of elastic material, right?
Yes.
So basically, if you just collide one tennis ball with the other, so you know that after collision, they will bounce back with almost the same momentum and same energy, right? But if we collide one complete hard snooker ball with the other one, like or cricket ball, so you observe that they will not bounce back as much as the tennis ball or the football will, right? So
Yeah.
basically, in elastic collision, we consider also the gas molecules, that the collision of the gas molecules is also elastic. It means their momentum and energy remains conserved after collision, before collision, right? And we studied about the concept of momentum only. The formula for momentum, half m1 u1 plus m1 v1 is equals to m2 u2 plus m2 v2. So we already discussed and we already solved the questions related to law of conservation, right? So same we have to apply on kinetic energy also, because we are talking about the collision, and during collision you know that bodies are in motion. So the energy that is linked with the motion of a body is known as kinetic energy, right?
Okay.
So let's suppose if we want to drive the formula for the kinetic energy before and after collision. So the kinetic energy before collision will be equals to, so let's suppose if we consider the same two objects and two objects collide with each other. Let's suppose if we are having two objects over here.
Okay. So when they collide with each other, they won't like stick together. They will
Yes,
continue
they
their
will bounce
separate
back.
ways.
Yes, if both are moving in opposite direction like this. So after collision, they will bounce back in this again opposite direction, right? One goes towards
Also,
right and second will towards left.
so when
Yes.
it's going towards right, the
Mhm.
momentum will be positive, and it's when
Yes.
it's going toward left, it's gonna be negative.
Yes. So basically, in this, the objects are not going to stick together. They will move in the opposite direction after the collision. So we apply the same example for law of conservation of momentum, but we didn't discuss about the concept of the kinetic energy over there. So we know that the initial
Okay.
velocity and the momentum of the bodies will be m1. u1 is the initial velocity for body 1, and u2 will be the initial velocity of body 2. And after collision, they will move in the opposite direction. So let's suppose if they collide with each other, and after collision, m1 will starts to move towards left hand side. M1 starts to move towards left hand side, and m1 starts to move towards right hand side. So again in opposite direction, right? And
Right.
the final velocity after collision will be v1 and v2. Okay. And we know the formula for kinetic energy is equals to half mv square. So by taking the reference from the formula, we start the equation like this, that let's suppose before collision, the kinetic energy of both object will be equals to half m1 u1 square plus half m2 u2 square, right?
So it's gonna be half
Kinetic,
m1 u1 square.
yes, because we know that the formula for kinetic energy is half mv square, so that's why we apply the same formula on both bodies before collision. And we know that
So
in
basically,
hmm,
wait, so the concept from this chapter is that the kinetic energy also remains conserved. So the kinetic energy before and after is the same. It's equal.
yes, yes. So that's why we just considered the equation before. So that's is the same derived from the formula of kinetic energy, and that is the sum of kinetic energy of individual bodies. And same goes with the After collision formula, so after collision we just write the same formula, half m1 v1 square plus, okay. And according to the definition of elastic
So
collision,
what we know
energy will
is
remain.
we
Hmm,
can say half m1 v1 square plus half m2 v2 square is equal to half
equals to,
m1
yes,
u1
yes,
squared.
same concept, just like the law of conservation of momentum, right?
Yep.
So that is the uh, equation for kinetic energy, right? So basically the new concept that we need to study in this thing, that sometimes in question they will ask about the elastic collision. So we need to know that what is the concept of elastic collision. So we need to compare the energies plus the momentum before and after collision of two bodies, right?
Right.
And same goes for the inelastic bodies when they are going to collide with each other. So we use the same equation, but you will get different results, right? Like initial
Okay.
energy will be different from your final energy. Definitely your
Okay.
initial energy will be greater, because after collision they lose their energy in the thermal heat, in the friction, or in different other types of energy. So your final kinetic energy will be less than the initial energy, right?
All right.
So in simple words, we can say that your total energy will be equals to kinetic, that is again half mv square, and your energy will remain conserved. While as if we consider the inelastic collision, so in inelastic collision, your final energy will not be same. Okay.
It's not the same because no energy is conserved. Like it's
Yes.
not con
Yes. So your energy, because we consider this whole procedure to be followed in an isolated system,
So there's no like extra
no
forces
external.
acting on
Yes.
them. Okay, also the inelastic collision is like when they stick together.
Yes, in elastic they will
Okay.
stick together and they will not move in the opposite direction, right?
They go in the direction of the one which has more speed, more
Yes,
momentum.
more momentum or more energy or more speed. Further in this chapter, there is a concept of drag forces.
Okay.
Do you know about the drag forces?
Yeah, it's like the friction, but
It's like the
friction
friction.
is for like solid, but drag is
Yes,
for like air.
air. Because when air molecules act on the object in opposite direction, so let's suppose object is moving in forward direction, so air resistance will act in backward direction, just like the friction. So the direction of friction and air resistance or the drag will be in the same direction. So if both are equal, so it means body is moving with constant speed. And if your frictional force is greater, so it means your object starts to decelerate. And if your driving force is greater, so it means body is accelerating. Okay. Any confusion?
No.
Okay. So basically in dynamics, we only need to study about those Newton's law, but you know that in questions, there are some advanced applications, some advanced concepts. Examples will be a little bit more complicated as compared to the previous we did in IGCSE. And after that, in this chapter, basically in this section, in dynamics, there is nothing more new for you in the chapter, because you already know about the Newton's law, all the things. So that's why we don't need to revise them. And
Wait,
after
the Newton's law is that the object which is in motion stays in motion, right?
uh, with the concept of dynamics, basically in dynamics, we are working with the reference of forces, that we have to study about the cause of motion also, right?
Yeah.
Kinematics, you know that we didn't discuss about any type of force. We just talk about acceleration, speed, velocity, time, distance, displacement. That's it. There is no involvement of force there. Okay.
Okay.
So basically in dynamics, we don't have such topics to study. That was new for you. all things are like from the basics, but application and questions will be like little bit typical. So let's suppose if we consider some questions from the dynamics, and after dynamics you have to start the concept of work energy power, and in work energy power and work done there is a concept of same principle of moment, torque, equilibrium, center of mass. So that is the
Okay,
concept
so they have
included
the
in your,
moment.
yes, the pressure, all things is going to be included in your next chapter, that is work energy power. And before that, because you already have good concepts, so you don't need to revise all the concepts. So if we start with some questions related to kinematics and dynamics, let's find that at which level you are able to solve the questions.
Okay.
Okay, so from this chapter, from this paper, we solve question number one, that is from chapter number one. We also solve question number two, that is from kinematics. Okay, now this question number three is like a combined concept from dynamics, density, work done. So let's try to solve this one because this question
Okay.
is from your dynamic section. So there are some values given in the question.
Yeah, so we know that the density of water is 1,000 kilogram per meter cube.
Yes. So
We know that the
basically, yes,
cross-sectional
cross-sectional area
area
is given, velocity is given, density is given, and all things are mentioned in the diagram. So basically, a jet of
Mhm.
water hits a vertical wall because you know that water starts to flow. So that's why there are some marks on the wall also, right? If it is a solid object, so it will bounce back. So basically, the water
Right.
runs down the wall after hitting it. Show that over a time of 1.6 second, time is 1.6
Mm-hmm.
second, the mass of the water hitting the wall is 1.2 kg.
So what we can do is we can use the formula density equals mass over volume. Since we
Okay,
already have density and we don't have a volume, but we can find the volume by using the cross-sectional area, right?
okay, cross sectional area, and
And
you need one more length to find out the
we
volume,
need
right?
how do we find it? Like, do we use the speed, distance, time formula to find that length?
Speed, distance, yes, you may also use that if that will help you to find out the distance. Because in question, density, velocity, cross sectional, these values are given.
Yeah. So we know that
Hmm.
the speed is 5 meter per second,
Okay,
and but they haven't given us the time.
the time is 1.6.
Okay, so the time is 1.6. So the speed equals distance over time, meaning that distance equals to speed times time, which is gonna be 5 times 1.6.
Okay,
That will give you
the value of the distance, right?
right.
So basically, we know that the cross sectional area is given, but this distance is not given.
So it's gonna be 8 meters.
Okay, so from this formula, we know that we have to multiply this concept. So you will get the value of mass. Okay,
Right.
because for the volume, you know that volume is not completely given over there. So for that purpose, you just use the formula of the distance is equals to, we will speed into time.
And you get 8.
And now we can
So
easily
then
use the
volume,
formula of, yes, density again to find out the mass.
or we can find the volume by multiplying 8
Multiplying, yes.
by
So
1.5 times
density,
10 to the power. Okay, so the volume is 0.0012 meter cubed.
okay.
So
And
when you multiply that by 1000, it's gonna give you 1.2
okay.
kg.
So that is the requirement of the question, that you have to prove your mass is equals to 1.2 kg. Okay, so you are getting the same answer.
Yep.
So you can see that questions are from the basic concepts only. They just give you indirect value. You have to just drive the values by yourself and reach the final answer.
Mm.
And the next concept is calculate the decrease in the horizontal momentum of the mass of the water in A due to hitting the wall. So we have to find out the decrease in momentum. And you know that the formula for momentum is mv. So in first part, they
Yeah.
gave you the concept of mass. So you already calculated the value of mass. Mass is 1.2,
And the speed is 5.
speed is 5. So your answer will be,
Oh, can't we use a different
hmm,
can't we use um see, we know that change in momentum, they're asking for change, right?
yes.
They're asking for the decrease. So change in momentum is equal to impulse, and impulse is equal to force multiplied by time. So what we can do is we can change the mass into force by multiplying it by 9.81,
But you will
right?
get the same
1.2.
answer, because in question they mention show that over a time of 1.6 second, the mass of the water hitting the wall is 1.2.
Mm-hmm.
You know that mass remains same, right?
Yeah,
So that's why we use the
but
same value, and velocity will also be the same. And if you use the concept of force divided by time, so you will also get the same result. If you want to give it try, so you may try by yourself. For that, you will get the
I
same
tried it.
answer. Hmm. So what
I
is your
got
final answer?
18.8.
18.
Yeah, because you have to first change the mass into force by multiplying it by
Okay.
9.81. And then I multiplied it. Oh, I multiplied it by 1.6 because that's the time.
Hmm.
And I got 18.8.
Uh, but for this part, they are asking the decrease in the horizontal momentum of the mass in part A due to hitting the wall. So they are just asking due to hitting the wall. We just need to find out the momentum of that. They are not asking that
Oh, okay.
before collision and after colliding with the wall, right? So that's why they are asking about only basic horizontal. Might be they ask in the next part that with reference of force or after the collision, what will be the value. So let's see in the next part. So for the first part, you just need to use the basic formula, that will be equals to
6.
6.0, right?
Right.
And we are writing 6.0 because we know that the concept of two significant figures. Okay.
Okay.
Yes, in next part, they are asking about the horizontal force. So now you have to use that formula.
Okay. So in B part 2, what we need to do is we can take the time, not
Yes.
the time, the decrease in momentum, so 6, and we divide it
Hmm.
by 1.6, and you will get 3.8.
3.8, right?
Yeah.
Okay. Till now, question is very much from the basics. There is no like a typical or advanced thing they are asking about. And in the next part, they are asking state and explain the magnitude of the horizontal force exerted on the wall by the water.
Okay, so the
Basically,
magnitude is going to be
hmm,
3.8 Newton.
okay, we already calculated that force. So now they are asking,
But how
state
do
and
I explain
explain
that?
the magnitude of the horizontal force exerted on the wall by the water.
So how do I explain that?
So basically, do you know about any law that gives you the concept of action reaction?
Yeah, the law where it's like
Newton's third
there's like
law.
an opposite reaction
Yes.
and stuff.
So you need to explain with the concept of Newton's third law, right?
So I'll just say because of Newton's
Yes.
third
Newton's
law,
third law, the
since it
force applied
applies.
by the water on the wall will be equal to the force exerted by the wall on the water, right?
Okay. So Newton's third law applies to this, so it's gonna be
Yes.
3.8 Newton.
Because they are not asking about the exact value, they are asking about the explanation. Will be equal to the force on the wall, right? And
Okay.
finally, they are asking about the pressure exerted on the wall by the water.
Okay, so we know pressure is equal to force over area,
Hmm.
and we calculated the force in part B too, so it's
3.8.
gonna be divided by 1.5 times 10 to the power of -4, which was our cross-sectional area. And you will get mm, you're gonna get 2.5 times 10 to the power of 4.
2.5, 10 to the power 4.
Yes.
So your answer is 25,000, right?
Yeah.
Okay. So you can see that question is pretty simple in this paper. Let's check out another one.